The Stone Age is the longest chapter in the entire story of our species. It began roughly 3.4 million years ago, and it did not end until barely 4,000 years ago, when the first metal tools finally replaced it. For almost the entire span of human and pre-human existence, a sharpened rock was the most advanced piece of technology any of our ancestors had ever held. And here is the detail that should change how you think about that fact: we are not the only ones who have done this. Chimpanzees use stones to crack open stubborn food. Long-tailed macaques in Southeast Asia do the same. Capuchin monkeys in South America have been documented using stone tools so consistently, over such a long period, that researchers have actually found the discarded, worn stone hammers themselves, tools bearing the unmistakable wear patterns of repeated use, dated back 3,000 years. An entire archaeological record of a non-human Stone Age, sitting quietly in the South American savanna, largely unnoticed. If a handful of monkeys can leave behind 3,000 years of stone tool use without anyone composing songs about it, the question becomes impossible to avoid. Life on this planet has existed for billions of years. Dinosaurs alone ruled it, almost completely uncontested, for more than 160 million of those years, a span of time so vast that it makes the entire length of human existence look like a rounding error. They diversified into an almost incomprehensible number of species and body forms. They survived multiple climate shifts, sea level changes, and minor extinction pulses across that entire reign. Surely, somewhere in 160 million years and untold thousands of distinct species, the right combination of brain and circumstance arose at least once. So we have to ask the uncomfortable question directly. Did dinosaurs ever have a Stone Age of their own? The honest answer is no. But it is a no with an asterisk attached to it, and that asterisk is where this story actually becomes unsettling. Across the entire history of paleontology, not one piece of strong, confirmed evidence of deliberate tool use has ever been recovered from any dinosaur, in any group, from any place or time period. No worked stones. No hammerstones. Nothing resembling the worn artifacts left behind by a 3,000-year-old Capuchin colony. Based purely on what has survived in the rock, the fossil record says clearly, it never happened. But here is the caveat that should sit with you longer than it probably will. The fossil record is not a faithful witness. It is an almost criminally incomplete one. Of all the bones that have ever existed on this planet, researchers estimate that less than 1 in a million has ever actually fossilized. That is bone, the hardest, most durable, most fossilization-friendly tissue an animal can leave behind. A worked stone, used briefly and then discarded onto open ground, has almost no chance of being recognized as deliberate at all, let alone preserved, let alone found, let alone correctly identified as evidence of intelligence rather than coincidence, tens of millions of years later. The absence of proof is not proof of absence. It may simply be the silence of a recording system that was never built to capture this kind of evidence in the first place. And once you start looking closely at dinosaur brains rather than dinosaur bones, the picture gets considerably stranger. Not all dinosaurs were equipped the same way. Some were, by any reasonable measure, remarkably unintelligent. A stegosaurus weighing 5 tons carried a brain roughly the size of a walnut. The largest sauropods, animals that could reach 100 tons in body mass, carried brains comparable in size to a tennis ball. For context, the human brain, attached to a body weighing a fraction of a ton, is roughly 8 to 10 times larger than that tennis ball. The giants of the dinosaur world were not, by any stretch, the deep thinkers of their era. And there is a colder logic behind that fact: brain tissue is metabolically expensive to build and maintain. In a world saturated with predators large enough to kill almost anything, investing limited biological resources into size, armor, and raw defense was simply a better survival strategy than investing in intelligence you might never live long enough to use. An ankylosaurus carrying a bone club capable of shattering a predator's leg did not need to outthink anything. It needed to see the threat and swing. That said, even these supposedly simple-minded giants were not entirely without resourcefulness. Sauropods and hadrosaurs have been found with stones, gastroliths, preserved inside their stomach cavities, swallowed deliberately to help grind tough plant matter during digestion. It is almost certainly an instinctive behavior rather than a calculated decision. But it is, in its own small way, a dinosaur using a stone for a purpose. The line between instinct and intention is exactly where this entire mystery lives. The real candidates for dinosaur intelligence sit elsewhere entirely, among the theropods, the largely carnivorous branch of the dinosaur family tree that, on average, carried significantly larger brains relative to body size and considerably higher neuron counts than their plant-eating relatives. And even within the theropods, the divide is severe. On one side sit the carnosaurs, the heavy-bodied, bone-crushing apex predators. On the other side sit the coelurosaurs, the lineage more closely related to birds than to anything resembling a traditional movie monster dinosaur. It was the coelurosaurs, almost without exception, who carried the highest neuron counts in the entire dinosaur family tree, and it is here that the debate over dinosaur tool use becomes genuinely heated. A widely discussed study examining the brain endocast of Tyrannosaurus rex estimated its forebrain neuron count at somewhere close to 3 billion, roughly 10 times the neural capacity of a 100-ton sauropod, and more than that of a baboon, an animal already documented throwing stones and using rocks to crack open hard-shelled fruit. The researchers behind that study went considerably further, suggesting that an animal with this neural capacity may have had the raw cognitive horsepower to solve complex problems, fashion crude tools, and even transmit learned behavior across generations, particularly given how long an individual Tyrannosaurus may have lived, long enough, in theory, to pass knowledge down to its offspring the way an elephant or a chimpanzee does today. It is a genuinely unsettling thought. An apex predator, already terrifying on physical terms alone, possibly capable of culture. But the criticism arrived almost immediately, and it is worth taking seriously. A high neuron count is not, on its own, proof of intelligence in any functional sense. What matters just as much is where those neurons are concentrated and how they are wired together. Many researchers now believe that the Tyrannosaurus brain's neural density was overwhelmingly dedicated to processing extraordinarily powerful sensory input, particularly an exceptional sense of smell, rather than abstract problem solving. And there is a far more basic, physical obstacle standing in the way of any Tyrannosaurus tool-making theory: its body. Short, gracile forelimbs with limited reach and weak grasping ability are simply not built for picking up, manipulating, or shaping an object with any precision. A massive skull and enormous bone-crushing teeth are equally unsuited to the kind of delicate handling that tool creation actually requires. Whatever was happening inside a Tyrannosaurus skull, its body had already disqualified it from ever acting on it. Which is exactly why the most serious candidates for a dinosaur stone age were never the giants at all. Move away from the tyrannosaurs entirely, toward the smaller, feathered theropods, the dromaeosaurs, with encephalization quotients reaching as high as 5.8, placing their relative brain size in roughly the same range as modern predatory mammals like dogs or house cats. Not the door-opening, problem-solving creatures of popular fiction, the real evidence does not support that level of sophistication, but genuinely capable animals nonetheless. And even the dromaeosaurs were not the smartest dinosaurs that ever lived. That distinction appears to belong to an even smaller, even more bird-like group, the trudontids, the ornithomimids, and the earliest true bird ancestors, the archaeopterygids. Across every measurable group of dinosaurs, one consistent and slightly eerie pattern emerges. The closer a dinosaur's anatomy moved toward what we would now recognize as a bird, the more capable its brain appeared to become. The trudontids deserve particular attention, because the evidence surrounding them is more than just brain case measurements and statistical extrapolation. Their nests show a level of structural complexity well beyond anything documented in other dinosaur groups, with clear evidence of deliberate manual shaping rather than simple instinctive scraping. Their reproductive biology, the documented metabolic signatures preserved in their fossilized eggs, closely mirrors that of modern birds, suggesting a physiology, and possibly a cognitive style, much closer to a bird than to a typical reptile. Combine that with genuinely dexterous hands, long forelimbs ending in 3 well-developed, independently mobile digits, and you have an animal that checks nearly every physical box a tool-using creature would need to check. It was exactly this combination of evidence that led paleontologist Dale Russell to propose one of the most genuinely unsettling thought experiments in the entire history of dinosaur research. If the troodontid Stenonychosaurus had survived the extinction event that ended the Cretaceous, if it had simply been given more time, the way our own ancestors were eventually given more time, its descendants might have followed an evolutionary path disturbingly close to our own. Larger brains. More dexterous forelimbs. A fully upright posture freeing the hands for manipulation rather than locomotion. Russell called the hypothetical result the dinosauroid. The proposal was, predictably, met with heavy scientific skepticism. But the fact that a serious researcher could construct that argument at all tells you everything about how close some dinosaurs may genuinely have come. And here is where the story turns from speculation into something almost guaranteed. We do not have to debate this in the abstract, because the descendants of the dinosaurs never actually went extinct. They are alive right now, and they have already done what we have spent this entire story wondering whether their ancestors were capable of. Birds, the literal living dinosaurs sharing this planet with you, are already, demonstrably, tool users. Certain corvids and parrots display cognitive abilities comparable to great apes. One documented gray parrot demonstrated problem-solving ability comparable to a 6-year-old human child. Crows and ravens display some of the highest neuron densities ever recorded in any bird's brain. Birds with longer developmental periods and more complex social environments consistently show higher measured intelligence across the board, the same pattern, almost exactly, that researchers see when comparing intelligence across different mammal species. And when it comes specifically to stone tool use, the living dinosaurs have already crossed the line their ancestors may never have managed. Trinidadian motmets use stones on the forest floor as fixed anvils, smashing the shells of arthropods and snails against them with precision. Egyptian vultures pick up rocks directly with their beaks and use them as hammers to break open ostrich eggs too thick to crack any other way. Crows have been observed deliberately dropping stones into water vessels specifically to raise the water level high enough to drink from, a documented, repeatable, deliberate solution to a physical problem, performed by an animal with no hands at all. Some ravens have even been observed dropping stones onto threats from above as a deliberate act of aggression, demonstrating a working understanding of cause, effect, and consequence that goes well beyond simple food acquisition. The detail that should genuinely unsettle you is not the stone use itself. It is what corvids do after they learn it. Multiple species have been documented watching tool use performed by other animals entirely, including by us, and then replicating it independently. And they do not stop at replication. They teach it. To other adults in their group, and critically, to the next generation. That single behavior, the deliberate transmission of a learned technique across generational lines, is considered by researchers to be one of the essential, non-negotiable building blocks of any genuine Stone Age, in any species, on this planet. It is not simply tool use. It is culture in its most basic, recognizable form. And corvids have gone further still. Several species construct hooked tools from twigs specifically shaped to extract grubs from tight spaces, a documented behavior with a genuinely uncomfortable parallel. Barbed, hooked tool technology does not appear in the human archaeological record until roughly 90,000 years ago, a development that occurred deep into the existence of fully modern humans, not at the dawn of our species. A bird, with no hands, no opposable thumbs, and a brain weighing a few grams, independently arrived at a category of tool design that took our own lineage hundreds of thousands of years to reach. Some of the most capable corvids have even been documented constructing tools from multiple separate components combined together, a meaningfully more advanced category of toolmaking than simply shaping a single stick or stone, and one that very few non-human animals on this planet have ever been shown to achieve. Taken together, this is not a stretch of the imagination. By any reasonable definition used to describe early human technological behavior, the descendants of the dinosaurs are already living through something that looks remarkably like their own Stone Age, quietly, continuously, almost entirely unnoticed by the species currently convinced it is the only one capable of having one. There is a thought experiment worth sitting with as we close this story, and it is considerably darker than it first appears. If every great ape on this planet, our own species included, were to vanish tomorrow, and the birds simply continued doing exactly what they are already doing, solving problems, building hooked tools, teaching their young, passing knowledge silently down through unbroken generational lines, it raises an uncomfortable question about whose turn might come next. They already have the long lifespans, the complex social bonds, the communication systems we are still working to fully decode, the capacity to teach. Every single ingredient our own ancestors needed to climb out of their own stone age is already present, right now, in the skies above you. The asterisk on this story, in the end, is not really about the dinosaurs that came before. It is about the ones that never actually left. If this story stayed with you, drop a comment and tell me which detail unsettled you the most, the T-Rex neuron count, the troodontid that almost became something disturbingly close to us, or the crow that is, quite literally, teaching its children to use tools right now while you read this. And tell me where in the world you're watching this from.